Hello everyone. I have built and trained an artificial neural network for XOR logic in Excel from scratch and shown the visualization using the Python code. If you see on my screen, I'm showing I'm starting with the forward feed or forward propagation. While most people use complex libraries for this, I have built the whole mechanics from scratch in Excel to make every calculation transparent. This approach provides a unique step-by-step view of how forward as well as backward propagation actually works and the complete mathematics which is involved in it. If you see the working copy, in case you need this working copy, kindly share your name or email in the comment section. I will be happy to share it with you. So I have used around 350 epoch to train the data to minimize the loss, and same is depicted with the working Python code, where you will see the steep drop in the error. So without wasting time, let's get started. So what is machine learning? Machine learning is a branch of artificial intelligence that enables computers to learn from data and improve their performance on a specific task without being explicitly programmed. That is the difference. You're not programming it, it is learning by its own, which involves building mathematical models based on sample data, which we also call as training data, to make decisions or predictions. The core idea is that the system should learn to identify patterns, generalize from examples, and adapt the behavior over time. So, what are the types of machine learning? Predominantly, there are four types of machine learning. One is supervised learning. This is the most common type where the algorithm is trained on a labeled data set. The goal is to learn from a mapping from input to output, so it can predict the output for new unseen data. The second type of machine learning is unsupervised learning. In this approach, the algorithm is given unlabeled data and it must find itself the patterns and the structures or relationship within the data on its own. Then comes the reinforcement learning. This type of learning involves the agent that learns to make decisions through trial and error basis. And then finally comes self supervised learning, also known as SSL, where a new way of learning the data has been done, where it sits between supervised and unsupervised learning. It trains models to understand data by generating labels from data itself, and like example predicting the missing image and then using that as a self generated label for training. So there are a lot of real life examples of machine learning which you are already using. I will just quickly give a gist about it. Like email filtering, product recommendations in Amazon or the tweets, voice assistants, medical diagnosis, automotive autonomous vehicles, and financial fraud detection. So possibilities are endless. Now in my problem, if you see, I have choose specifically the XOR. Why I choose XOR problem? Because it's a classic machine learning example, because it demonstrated the fundamental limitations of single layer neural networks, which was known as perceptron. This was the reason in 1970s when there was a huge halt in the artificial intelligence implementations, because there was a limitation. Single neural network was not able to predict a straight line. When I say straight line, you can see on the screen, this is a simple or, and in case, I mean, in the AND gate also, you can see where you can segregate the data. In OR gate, this is the truth table. You can see when it is 0 0, then only the output is 0, rest all the three times it's 1. So it's easy to fit a line which will classify the data. But you can't do it in XOR because it's non-linear nature. You can't put the line here or you can't do the same like this. So this was a classic issue that needs to be solved. And how they achieved it? By introducing multi neuron in the system, through which they were able to achieve it. Now if you see on my screen how it works, generally you will have inputs, you will have weights and some bias. The calculation goes like this. At this point in time, where the output Z3 is summation of x1 into weight 1 plus x2 into weight 3 plus the bias b1. That is the output of Z3. If I have to write it, I could quickly write it x1 w1, okay, into x2 w3 plus b. That is the output at this point, Z3. Similarly goes for the Z4. Then finally, this is the trick here. If you see, this data or the net total is passed to the activation functions. So we have different type of activation functions. Okay, mainly we use sigmoid, tan, h, and relu are quite common, but you can see all of them I have tried to show here. So what exactly it does? So sigmoid, whatever the data is passed, it tries to fit it between 0 and 1. Okay, tan h is mainly between minus 1 to 1, the output, it translates the output, tries to fit it into that. Relu is mainly from, if you see here, from 0 till the number. So there we get some problems related to dying neurons, because anything less than 0 is not at all considered. Those neurons never get activated. So what happens, if it fits the criteria, the neuron gets activated and you get the output here. So once you have the output from Z3, when you apply the activation function, if the neuron gets activated, it's like a brain cell. One neuron activates the another neuron activates the third neuron, and so on. In this process, this is how the artificial neural networks learn. Now imagine if the data was not activated, so output will be 0. If the data is activated, which is mainly, if you see, it is one sigmoid function. I have used sigmoid function in it, which is 1 plus e raised to power x. This is the sigmoid function. So here, what is this? This is the a3. So 1 plus e raised to power 3. So finally, you have weight 5, weight 6, same 3. A3 into w5 plus a4 into w6 plus b3. That becomes the final z5. Again, we will pass it to the activation function, and that gives us the output, okay, desired output. Now, when you have a desired output, what is the expected result? As we have seen in the truth table, so imagine if you got the output as some weird number, let's say, because initially we assign all the random numbers to these weights and bias. Input is fixed, where you will have, in XOR case, you will pass 0 comma 0, 0 comma 1, 1 comma 0, and 1 comma 1, all four permutations, which are quite possible. So then this is where we call it, this process where we calculate the error. You can see here, error, or some people call it cost function also, is expected minus desired output. Let's say, imagine the expected result was 0, but you got 1.1 or 2 or something. So this is how we calculate the error. Okay, and this process, now what we do with this error, this whole process is called gradient descent in machine learning, which we use because it's an iterative optimization algorithm that trains models for finding the lowest point of a cost function. So the whole purpose of this network is to reduce the cost. So how it will reduce the cost? By taking small steps in the direction of the steepest decrease, negative gradient. So how we do that? We adjust these weights and biases. So how we do? We propagate the error, okay, using calculus, calculus differential derivatives, where we propagate these errors and see what effect it has on weights and subsequent bias. That is the whole purpose of gradient descent, or as I said, we'll move to the next tab, known as backward feed propagation. Here we are propagating the error, okay, from here till here, and subsequently it keeps on going until we find the delta part for all these values, w5, w6, w3, w4, B1, B2, B3, W1, so that we have the new revised weights and bias. And we again keep on iteratively keep on passing to our network, so that networks keeps on learning until and unless it tries to hit the cost function towards zero. That is the whole purpose. And we assign some learning rate also into it that I will show you here. So this is our working copy of a excel. Don't get scared initially. It has all the mathematical calculations which we will see now. We have around, if you see 350 epoch which I have mentioned, you will see, can you see the cost function is slowly minimizing to 0.25. If you further drag and drop, let's say around 10,000 or 8,000 iterations, our cost will be around 0.01, which is the right prediction. It has made the right prediction of the values of the output. When it is 0 0, it should be 0. So if you download this excel, just try to look at what I have done. I will try to high level cover it, otherwise it will take a lot of time. If you have any specific question, just feel free to ask me regarding the calculations about it. But if you see, we have the weights, which I can show you here. These are the weights: W1, W2, W3, W4. These are the weights, W1. Then the bias, these are randomly assigned. You can assign on your own. Then you have a learning rate. The more you put the learning rate is something like you're going down the hill. So you want to go step by step rather than taking the huge steep curves. You will miss the data. That's why the less the learning rate, the more time network takes to learn. But it comes with its own pros and cons. It has a lot of computation power is required if your learning rate is less, because the network is slow. It's training learning with its own slow pace. So when you see, now we have all these values, and these are our input x1, x2, and output is y0. First thing what we have calculated is, if you see, this is what I have been telling: weight 1 into x1 plus weight 2 into x2 plus bias. Then we passed it to the sigmoid function. If you see our activation function, this is 1 plus exponential of the Z3. So this way we have calculated our A3, A4 are nothing but the activation functions. Same goes for Z5 and A5, which you can see here. Z5, okay, and A5. This is how it has got calculated. And then finally, this is the trick here. I won't be able to cover each and every bit of it, but in case you need any help, or I may cover it in subsequent videos, that how derivatives are calculated for sigmoid functions, or for the constant, or for the inputs, how it is calculated. But currently you can look at here, and you will see all of them are calculated. So for all the four possible inputs, we have specific output, but the system has predicted. You can see here we have sum total of loss. I have took the sum. Some people take it average. So there are different type of gradient descent also. I have used the batch one, but there are some people use sampling one also, or stochastic uh, gradient descent also. So this way, once we have all the delta parts of weight 5, weight 6, bias 3, then finally, if you see in epoch 2, what we are calculating, we are just using the learning rate B12 minus this learning rate into that part. We are subtracting that part. So biases and weights are getting adjusted, and under each epoch, it just gets calculated. I want to show you a working Python code, which you can see on my screen. This is the same code which I will share in case you're interested. So you can see here, these are our inputs. This is our output, desired output. Same 350 epochs. Learning rate I have kept 3, same as Excel. And initial weights I have kept same. Bias I have kept same. And you can see here where I'm printing when the error is less than 0.001. So we have converged at that epoch. But since I have just used 350, but you can try with 10,000 iterations, you will see, you will get the result. So what I'm trying to show you here is essentially how we started, and how after 350 epoch, how the error is getting minimized. I have tried to summarize this whole. I know it takes comprehensive time to understand it, so that's why I would first appreciate you first download the excel, which I will send you. Just go through it, check the calculations, validate it by yourself, uh, look at the sample code which I will be sharing with you guys, and share your feedback. I'll be more than happy to help you. Keep learning, and in case you have any questions, feel free to ask.